All right, let's get into it. You know, you spend all day clicking, typing, and swiping away, but have you ever just stopped and thought about the invisible force that's making all of that happen? Today, we are pulling back the curtain on the single most important piece of software on your computer. Yeah, you guessed it, your operating system.
I mean, it seems so simple, doesn't it? You see an icon for your favorite app, you give it a double click, and boom, a second later, there it is. But what is really going on in that tiny little gap of time? Who or what is actually doing all the heavy lifting?
Well, that's where your operating system steps in. The best way to think about it is like the ultimate manager, or maybe an invisible conductor, orchestrating this massive symphony of hardware and software. Every single thing you do is basically a request, and the OS is the one fielding that request and making sure the job actually gets done.
Okay, so if the OS is a manager, what exactly is on its to-do list? Well, it provides this whole suite of absolutely essential services that let you and all your programs do their thing. So let's properly meet this digital manager and see what a day in its life looks like.
So what's job number one? What's arguably the most critical thing it does? Well, it has to act as your personal translator. How does it let you, a person, tell a machine that only gets ones and zeros what you want it to do?
It's all thanks to something called the user interface, or UI for short. This is the service that, for all intents and purposes, lets you talk to your computer. It's the bridge between our world and the machine's world, and it comes in a couple of different flavors. On one side, you've got the command line interface, the CLI. Think of that classic hacker movie terminal window where you're typing in these really precise text commands. It's incredibly powerful, for sure, but not exactly welcoming for beginners. And then you have what most of us use every single day, the graphical user interface, the GUI. This was a complete game changer. This moved to a friendly world of windows and icons and menus. Just by adding a mouse into the mix, the GUI made computing accessible to pretty much everyone. But the user interface is really just the tip of the iceberg. Your OS manager has this whole menu of services it's constantly providing, both for you and for the programs you're running in the background. Let's check out a few of them. First up, program execution. When you want to run an app, the OS is what finds it, loads it into the computer's memory, and actually gets it up and running. Then you've got I/O, or input-output operations. You might think you're typing directly into a document, but nope, the OS is the middleman, managing all the chatter with your keyboard, your mouse, your printer, everything. And of course, file system manipulation. The OS is basically your digital librarian, letting you create, delete, and organize all your files and folders.
The OS also has to play defense, right? And that's where its error detection service is key. Think about it. If your printer runs out of paper, your whole computer doesn't just crash. The OS catches that error. It tells you what's wrong, and it makes sure the rest of the system just keeps on chugging along. It's constantly stopping these little problems from turning into total disasters.
And so much of this is happening behind the scenes. The OS is managing communications between different apps, it's acting like a traffic cop, deciding who gets to use the precious CPU and memory, and it's providing protection and security, making sure one misbehaving program can't bring down your entire system.
Now, trying to manage all of this stuff creates a huge challenge, a fundamental conflict really, right at the heart of computing. And it all boils down to the problem of waiting.
See, your computer's processor, the CPU, is just ridiculously fast. It can do billions of things every single second. But you, well, you're not so fast. You type at human speed. Your hard drive is slow. Your network is slow. So what happens when this blazingly fast CPU has to hit the brakes and wait for a slowpoke like you, or a clunky old printer?
An idle CPU is a wasted CPU. It's that simple. Every single nanosecond it spends just sitting around waiting for you to type the next letter is a nanosecond of processing power that is gone forever. This inefficiency is the single biggest problem that an operating system has to solve.
So how does it do it? Well, this is where the OS becomes a master juggler, using these brilliant techniques to make sure the CPU is never, ever bored. And honestly, these techniques are what make our modern computing experience even possible.
The first key technique is called multiprogramming. The core idea is actually pretty straightforward. If you've got a bunch of jobs that need to get done, just organize them in a way that the CPU always has something to work on.
Okay, so here's how it works in practice. Let's say program A is running using the CPU. Then, all of a sudden, it needs to wait for something slow, like saving a file to your hard drive. Instead of just stopping and waiting, the OS instantly, and I mean instantly, switches the CPU's attention over to program B. Then when program B needs to wait, it switches to C, and so on and so on. The CPU never ever has to sit idle.
A great way to think of it is like this. A busy lawyer doesn't just sit in their office and wait for paperwork to come through on one case, right? No, they immediately pick up another client's file and start working on that. Your OS is that hyper-efficient lawyer, making sure that not a single moment of its precious time goes to waste.
Now, multiprogramming eventually evolves into what we experience today, which is multitasking, sometimes called time sharing. Multiprogramming is all about pure efficiency, just keeping that CPU busy. But multitasking adds another critical layer: user interaction. The OS switches between programs so incredibly fast, we're talking thousands of times a second, that it creates the illusion that everything is running at the exact same time. That's why you can be typing in a document while listening to music, while browsing the web.
All of this, the services, the resource management, that incredible juggling act, it all happens completely out of sight. And that really cements the operating system's role as the true unsung hero of our digital lives.
And its job is never finished, especially when it comes to security. The OS has to be vigilant everywhere, all the time, because, as they say, a chain is only as strong as its weakest link. If even one tiny part is left unprotected, the whole system can be vulnerable.
So, the next time you use your computer, just remember this. Your OS isn't some static, boring background program. It is an active, incredibly sophisticated problem solver. It's the complex engine that's juggling countless tasks, managing endless resources, and solving millions of tiny problems every single second, just to give you a smooth, interactive, and powerful experience. I mean, it's already mastered the art of multitasking for one person on one device. But as our world gets more and more connected, with AI and cloud computing and the Internet of Things, the challenges are only going to get bigger. So I'll leave you with this question. What's the next great problem you think our operating systems will need to solve? Thanks for tuning in.